Hi, welcome to Unit 7, Day 5, Limiting Reactant, Theoretical Yield, Percent Yield, Part 1 Intro. So as you know, we've been covering stoichiometry, which is using mole ratios to convert from the amount of one thing to the amount of something different. And in the first set of lessons that we looked at, we used subscripts and chemical formulas as our mole ratios to do that conversion. And then recently we started looking at problems where we use coefficients in the balanced chemical equation as our mole ratios to do that conversion. Today what we're going to do is we're going to apply our stoichiometry knowledge, specifically the knowledge related to using coefficients in balanced chemical equations, to tackle three new concepts: limiting reactant, theoretical yield, and percent yield. Now, these concepts are something that a synthetic chemist or a chemist who works in a lab to make things thinks about all the time. Because when you're doing a reaction, you're oftentimes trying to think about which reactant you're going to run out of first. You're also using that to sort of predict the maximum amount of product that you can make. And you're grading or rating your reaction on how effective it is at making that product. So before we dive into the topics, what I want to remind us is that stoichiometry involves two types of knowledge: conceptual and problem solving. This video really deals with just the conceptual understanding. For problem solving, there will be example videos in practice that you'll look at later. But having the conceptual understanding is important because when you're solving the problems, you still have to think about what you're doing in case a problem is set up differently or they throw in a curveball. So going back to this idea of using this analogy of cooking and in chemistry, this is an important analogy because the things that you do when you're cooking are the same things that you do as a chemist and you're performing a chemical reaction. So it's always important to keep in the back of your mind that your balanced chemical equation is your recipe. And the ingredients or the reactants are like your ingredients. It's what you're mixing together. And then your products are like the food that you're trying to make. And having that in the back of your mind will help you with these new topics. So before we get into defining limiting reactant, theoretical yield, and percent yield, I want us to use that idea of this cooking analogy to introduce those concepts. So we're going to do this first, CFU. Let's say you wanted to make grilled cheese sandwiches according to the recipe shown, which involves using 2 slices of bread, 1 slice of cheese to make 1 grilled cheese sandwich. And you go into your fridge and you discover that you have 12 slices of bread and 7 slices of cheese. Which ingredient limits the amount of grilled cheese sandwiches you can make? And I want you to explain. So you want to make some grilled cheese sandwiches. Are you going to be limited in making those sandwiches by the 12 slices of bread or the 7 slices of cheese? Pause the video now. When you press play again, the answer will be revealed. All right, the answer should be the 12 slices of bread. So let's think about how we sort of can explain this. If we look at the 12 slices of bread, according to this recipe, it's 2 slices of bread makes 1 grilled cheese. So 12 slices of bread would make 6 grilled cheese sandwiches. If we look at the cheese, it's 1 slice of cheese will make 1 grilled cheese sandwich according to the recipe. Therefore, 7 slices of cheese will make 7 sandwiches. Well, the fact is you cannot make more food than you have. So your reaction is limited by the 12 slices of bread because it can only make 6 sandwiches. After you make those 6 sandwiches, you run out of bread, you can't make any more. All right, next CFU. What's the maximum number of sandwiches you can make in theory from the 12 slices of bread and 7 slices of cheese using the recipe shown? Pause the video now. When you press play again, the answer will be revealed. All right, the most amount of sandwiches you can make will be 6 sandwiches because, as you know, the bread will run out after you make the 6 sandwiches and you'll have a slice of cheese left over, but you don't have any bread to use that for a sandwich. So 6 sandwiches is the maximum amount you can make. All right, now let's define limiting reactant and theoretical yield based on that cooking scenario. All right, limiting reactant is the reactant, which is like the ingredient, that limits the amount of product you can make because it runs out of first. And it's going to make the least amount of product. And that would be like the bread that we saw in the previous example. So the bread runs you run out of the bread first, and it makes the least amount of sandwiches. This 12 slices of bread can only make 6 sandwiches, whereas the 7 slices of cheese can make 7 sandwiches. Since you cannot make more than you have, that bread is the thing that limits the reaction. It's your limiting reactant. The theoretical yield is the maximum amount of product or food that can be produced in theory. So when you're looking at your scenario, it would be the 6 sandwiches, the maximum amount you can make from the 12 slices of bread and 7 slices of cheese, 6 sandwich. Now, the reason why we say theoretical yield is because reactions are not 100% perfect. But if they were, this is the most amount of product you can make in theory. So that's why it's called theoretical yield. All right, so how do we find limiting reactant and theoretical yield given our chemical reaction like the one shown? So in this example, if we had 1 mole of N2 and 1 mole of H2, and we were asked what's the limiting reactant and the theoretical yield of NH3, given this information that 1 mole of N2 makes 2 moles of NH3 and 1 mole of H2 makes 0.67 moles of NH3. So let's go ahead and pause for a second. First of all, this up here, this balanced chemical equation is my recipe. It's not what I actually have in my kitchen, let's say, right? It's just what my recipe calls for. My recipe calls for 1 N2, 3 H2, and 2 NH3. But if I go into my kitchen and I see I only have 1 mole of N2 and 1 mole of H2, I just want to know how much I could make with the amounts that I have. So remember, the limiting reactant is the reactant that gives you the least amount of product. So if you look at what they're giving us here, they're telling us 1 mole of N2 makes 2 moles of NH3, and 1 mole of H2 makes 0.67 moles of NH3. Well, the least amount of product it can make is the 0.67 moles of NH3. So that tells me that my limiting reactant is the reactant that makes that amount. So the H2 is my limiting. And the 0.67 moles of NH3 is my theoretical yield because you can't make more than you have. So so what you're doing in a problem like this is you have to figure out how much product you can make for each reactant and then choose the one that gives the least amount of product. Now, one thing I want to emphasize once again is that this up here, this balanced chemical equation, is your recipe. It's not what you have. It just tells you what the relative ratios are. What you actually had in this problem was 1 mole of N2 and 1 mole of H2. All right, let's take a look at another example. So in this case, we have 4 grams of N2 and 2 grams of H2. What's the limiting reactant and theoretical yield of NH3, given that 4 grams of N2 would make 4.87 grams of NH3? So what do I mean by that? That means if you had 4 grams of N2, an unlimited amount or excess amount of H2, you could make, in theory, your theoretical yield would be 4.87 grams. On the other hand, 2 grams of H2 with excess N2, like unlimited amount of N2, can make the maximum amount it can make is 11.2 grams of NH3. All right, so now based on these 2 pieces of information, which one is my theoretical yield and limiting reactant? Well, remember, we look for the one that gives us the smallest number. So N2 gives us the smallest amount of NH3. It gives us 4.87 grams, whereas the 2 grams of H2 gives us 11.2 grams of NH3. So we pick the smallest amount of product here. And then therefore our limiting reactant is N2 and our theoretical yield is 4.87. Now, one thing I want to note is that the limiting reactant is not the one that you have the least amount of it. It's the one that makes the least amount of product. So sometimes what people do is they'll look at the amount of reactant they have, 4 grams of N2 and 2 grams of H2, and they'll go, oh, that's a smaller number, so that's my limiting because I have the least amount of it. No, you can't do that. You actually have to determine how much product each reactant makes and then choose the one that gives you the smallest amount of product. All right, now it's your turn. You're going to try the CFU. If you had 15 grams of lead nitrate and 10 grams of potassium iodide, what's your limiting reactant and the theoretical yield, given that 15 grams of lead nitrate makes 20.9 grams of lead iodide and 10 grams of potassium iodide makes 13.9 grams of lead iodide. Pause the video now. When you press play again, the answer will be revealed. The limiting reactant here is Ki, and that's because it makes the least amount of product, PbI2. So you look for the one that gives you the smallest amount of product. And then therefore our theoretical yield would be that amount, the 13.9 grams. All right, next CFU. If you had 4 grams of zinc and 8 grams of HCl, what's your limiting reactant and theoretical yield of zinc chloride, given that 4 grams of zinc makes 8.34 grams of zinc chloride and 8 grams of HCl makes 15 grams of zinc chloride? Pause the video now, and when you press play again, the answer will be revealed. Right, so the answer here is 8.34 grams of zinc chloride. So remember, this is your limiting reactant because it makes the least amount of product. And your theoretical yield would be the corresponding amount of product, 8.34 grams. All right, so just in summary, limiting reactant is the reactant that you run out of first, and that gives you the least amount of product. It's not necessarily the reactant that's in the smallest amount. Theoretical yield is the maximum amount of product you can make in theory if the reaction is 100% perfect. Now, to find the limiting reactant and theoretical yield, what you need to do is, like in all these previous problems, is you need to determine the amount of product you can make for each reactant. So for each one, you figure out how much you can actually make. And then you choose the one that's the smallest. All right, so that is it for this video. The next video is on percent yield. Have a quality day.